So we're going to have a panel. So Austin's going to moderate, and we've got 4 panelists. So we're calling the panel H2 at UT. As I mentioned, we've got 80 faculty and staff who do research on hydrogen at UT, and we're going to hear from 4 of them. So Vaibhav Bahadur, who's Associate Professor in Mechanical Engineering, Emily Beagle, Research Associate in the Weber Energy Group here at UT, Michael Lewis, Director of Center for Electromechanics. Here they come, all right. Ning Lin, Chief Economist of the Bureau of Economic Geology. And, you know, this panel, I'm super excited to hear what they all have to say because they represent different aspects of the hydrogen research ecosystem at UT and have been really important in the high velocity hub effort, the hydrogen proto hub, just making UT great as a place to be. They're all great colleagues, so I'll let you take it away, Austin.
All right. Hey, welcome everybody. Thank you for coming out. I think we're running a few minutes ahead, so I hope I didn't throw you off too much. I'm thrilled at the makeup of this panel, and so Brian mentioned the backgrounds that we have here. We're going to talk really with leading experts in the realities of what's happening in hydrogen today across everything from early research to actual deployment, what happens in the markets, and how does policy make all that reality. So I'm really excited about all of that. We had a bit of an introduction then of who you all are. Maybe we'll just go down the road to start off and tell me what makes you excited about hydrogen. Mike, we'll start with you.
Sure. Well, welcome everybody. It's glad to see all the faces in the audience. I'm excited. This is our 2nd year doing this, so thanks Brian and Energy Institute. I guess what makes me excited about this is I've been doing hydrogen research for close to 20 years at this point. Wondering if I was ever going to be the cool kid in the room or, picked to be on the team. But here I am up here. In the last 2 years, we're really making a big impact with this event. I'm also happy to be up here with all my panelists. Everybody here to my left, they're friends in this hydrogen space, and much like you said, all the collaboration where you're doing together, different areas of research and expertise coming together, I think is very important. So thanks for having us.
Thanks, Mike. Ning, how about you?
Hi, everyone. Can you guys hear me okay? Okay, good. So I think my journey, well, I kind of came from academia after 18 years in the gas and chemical industry. So I have involved a lot of different projects of, infrastructure and downstream demand. So I think that my experience in the commercial world really influenced my decision of coming to academia and, also getting into hydrogen space, because I see that there are impactful topics right now that our industry will need deeper analysis and research-based solutions. So I think that's kind of what gets me excited. I have an opportunity to come to academia, which 5 years ago I joined the Bureau of Economic Geology and start my journey, and also started in the hydrogen space. So we can talk more about what we do, but my research, I'm part of the GeoH2 consortium, and my research really focuses on the commercial viability of a hydrogen value chain.
Love that. Great. VB, what excites you?
All right. Good morning, everyone. My name is VB. I'm an associate professor of mechanical engineering here. I've been at UT for 10 years, and before this, I was in industry for about 4 years, the oil and gas industry. So I'm much older than I look. And since the last 10 years that I've been here, I've been working on various projects related to energy, water, and over the last few years, that interest in energy has carried on to hydrogen. And I get a lot of students in my office hours who ask me what will happen to the oil and gas industry, and is there a career for me in the oil and gas industry? And my answer is a firm yes. And yes, we do need wind and solar, but we do expect oil and gas and hydrocarbons to be a part of the energy mix in the foreseeable future. And if it makes you feel better, you need not sell hydrocarbons. You can just sell the hydrogen and capture the carbon. And so I think these are two big opportunities for research, for enterprise, and that's some of the things that drive students. And on another note, I tell my PhD students that this is probably one of the best times to be a researcher in energy. I mean, there's never been so many grand challenges that need to be overcome, and we have a 2050 timeline, so it will happen in the careers of most of the students who are now at UT. So again, huge opportunities, and there's also a lot of funding here. I mean, all of us in this panel struggle to keep up with all the proposals that are coming out from the government and from other organizations. So again, enormous opportunity. I mean, that's what I see, that what drives me forward. And again, huge technical challenges, and I'm happy to talk about more of them. And in particular, one of the challenges is the water aspect of hydrogen, and that's something that all four panelists share in common. And specifically, we're looking at the Permian in Texas, and the produced water in the Permian is one of the hardest to treat. And can we treat that very difficult water and convert it into water that can go into an electrolyzer? I mean, that's really one of the grand challenge problems that all of us are looking at. So let me stop at that and move it on to Emily.
We'll probably come back to some of that water topic here in a few minutes. That's great. So Emily, what excites you?
Perfect. I'm excited because so many other people are now excited about hydrogen. Brian alluded to the size of the audience here this morning for the start at the 8:30. We now have sort of 3 days of Hydrogen Day activities for the second year. I can make tenuous claims that I was working on novel hydrogen production about 10 years ago when I was a graduate student. Nowhere near still the 2 decades that Mike has, but I sort of came really into the hydrogen space when I was working in Washington, D.C. on energy policy, specifically looking at policy to decarbonize the industrial sector, which is one of those areas, as you mentioned, Austin, where we really see the need for hydrogen, and then had the opportunity to come to UT about 2.5 years ago as part of this H2 at Scale project, working on all sorts of other hydrogen projects now with the panelists and others across UT. And I'll also echo that not only is it a really exciting time to be working on hydrogen as we sort of see this confluence of policies and industry interest as well as academic interest all coming together to really push to drive this industry forward and sort of addressing it across all of those different venues. But it's a really exciting time to be working on hydrogen in Texas and at the University of Texas because as we've already heard, as I'm sure we'll talk about across the course of today, that Texas is a really great place for hydrogen as well. So that excites me too.
Definitely. No, this is great. I'm loving the excitement. Let's dig a little bit deeper then into each of your specific areas of expertise. VB, I'll start with you, come back to you. What do you think we would be surprised to hear, or what do you want to share with us that's really on the leading edge of some of the research in this space? You talked about water, you talked about hydrocarbons, you can sell the H and capture the C. What are you seeing that's really on the cutting edge here with the work you're doing?
So again, there's a lot that I can talk about here. I mean, you have advances in all parts of the hydrogen value stream. So whether it's production, whether it's distribution, whether it's storage, application, and you have a lot of opportunities in each of these. And I think most people focus on the production side, so electrolytic hydrogen. And again, the grand challenge here is reducing the cost from, let's say, $10 per kilogram to maybe $1 to $2 per kilogram by 2030. And so again, the cost is a function of 3 things. It is the cost of it's the initial capex and the initial investment that goes in. What people don't realize is that we also need to increase the life of these electrolyzers and fuel cells. And again, if you double the life, your levelized cost over a 25-year period automatically goes down. So that's something that needs to be looked at. So it's not just the initial capex, it's also developing approaches to extend the life. So studying degradation of fuel cell catalysts, degradation of electrodes, and there's a lot of opportunities to innovate in that area. And so that's on the production side. On the transportation side, I mean, the real grand challenge is repurposing the natural gas infrastructure to transport hydrogen. And we can transport maybe 10 to 15% hydrogen blends in today's pipelines, but that is not good enough for a lot of applications. And what do we need to do to go from that 10 to 15% to higher blends of hydrogen? And again, there's lots of innovation needed in the material space. So hydrogen is the smallest molecule. It diffuses through plastics very easily. It will diffuse through steel pipelines as well. And how do we prevent that, and how do we monitor that? Because hydrogen itself is an indirect greenhouse gas, and the long-term implications of hydrogen leaks is, I'd say, not very well understood. So we need to understand that, we need to close that gap. So that's something that I know that people at UT Austin are working on it. But again, it's something that is important. So quantifying the environmental aspects of hydrogen and what happens if there is a hydrogen leak. And again, hydrogen storage and ammonia and low carbon carriers of hydrogen, I mean, that's another big opportunity going forward. And so I think these are some of the key areas that need attention from a fundamental standpoint. But what I would also like to say is that there's been a lot of research done on hydrogen in the last 20 years, and academicians are not great at translating their lab research into commercial products. And we do need academics working more closely with industry. And this is where things like NSF I-Corps and incubators and startup ecosystems come in. So I do think we need more of that effort and not less of it. We have a lot of people, smart people in academia, but they do need help in thinking bigger than the lab and going beyond the lab, and going from lab scale to pilot scale to commercial scale. So I think these are things that need a lot of thought and improvements going forward.
Yeah, let's talk about that a little bit, because one of the things from an industry side that we see is, you know, take electrolyzers, for example. If that technology is going to get better, if costs are going to come down, lives are going to extend, efficiencies are going to get better, we have to have some early applications of that to get on that learning curve. But then also to get on that learning curve, to get the applications, we need the markets to come along and start to evolve. And so Ning, maybe I'll come to you next. What's your view on the reality of the markets as they exist today? You know, what does it take? DOE talks about liftoff, right? What does it take to get to some further adoption here on the market side?
Yeah, so that's something that's really interesting, because I think yesterday the talk that Mike also mentioned, right? What is the biggest challenge? It's really not on the technology side right now. Because, you know, the technology for a lot of them, there's a lot of improvement can be done. But the most critical challenge we have is commercial. It's about market. And, you know, it's because besides of the existing market that can take hydrogen, a lot of them in our projection is emerging sector. And I think that's where I think the market is like, right now it's very fragmented and very niche, to be completely frank at this point. And that's why in our research, we really focus on kind of putting the pieces together. I wouldn't dare to say that we have a grandiose plan, we know how to all fits all. Based on my experience in commercial, everything comes in very messy, incremental steps. So at the very beginning, you know, that's why when we're looking at our research, we focus on market. But instead of having a big plan or to do a model, what we do is we look for business viability, business case. We first want to help the business and agency to look at the first step. How do they start? Where do they start? If they need to demonstrate a commercial viable business case, what do they need, right? So besides technology, what do they need? They need a clear vision of price signal. They need a firm offtake agreement of commitment, right? Those are the things that can get you, get bank support. And also they need a very established and clear regulatory framework, right? So these are the things. So I think that for a lot of the market right now is we're working on all these pieces, but we're kind of still struggling to put them together in one puzzle and to kind of all fit. And a lot of our work, that's kind of what we do. We kind of focus on exactly like geological storage. We focus on that. We focus on actually working with Mike's group. We look at the hydrogen from electrolyzer and then store it in salt cavern at scale and backup for the intermittency for the grid, right? So it's kind of looking for that niche product that actually can get the industry excited and see there's incremental ways they actually can move into market. So to me, the market is like, it's excited, but not quite jump on because there is no pathway completely figured out. So I think the industry is really, what is practical is to look at very smaller size, but good business sense type of viability cases for applications to really move our industry forward. And we are also start looking to ammonia, like others mentioned. So besides, that's one example. Everybody's looking at ammonia into export. But beside exports, we also start to have real conversation with agriculture sector domestically. Because forget about, we want to do export because we have wonderful, other nations have subsidy for it. But we cannot forget, we also have a mammoth fertilizer industry domestically. US is one of the largest producers of ammonia, and we still import 20%. So if we could, we just say we could, we start reach out to the agriculture sector colleagues, start having conversations. We say, look, you don't have to retrofit anything, you have the route to market. And 45V, DOE's already put money in on the upstream. We need some downstream synergy. Can we do something about it? So that's one thing get us really excited, is trying to find new ways to cultivate that conversation with our research to get the market moving.
That's great. There's a lot there to unpack, so we'll see how it goes for the rest of the time, but definitely conversations for the rest of the day. I have no doubt around, are there price signals, are there commitments, is there policy that brings all this together? I mean, Mike, you look at what is the reality of some of this in application. You look at how is the DOE moving at an early stage. How do you think all this is coming together?
Well, it is coming. We would love to see it accelerated. At my research center up at the Pickle Research Campus, we are trying to apply a lot of this fundamental research and the lessons and analysis that, say, Ning's doing, for example. The Hydrogen Proto Hub is a very unique facility that I think sets us apart from many other universities. We are effectively trying to build this hydrogen ecosystem, at admittedly a relatively small scale compared to industry, but trying to understand the synergies of the different ways of producing hydrogen, the different demand scenarios for hydrogen. What does renewable electrolysis look like on this hydrogen grid alongside hydrogen from natural gas, right? Which might be more steady state, right? We're going to see kind of a similar dynamic we might see with the electric grid there, and hydrogen being a piece that knits that all together. But then we might have larger industrial consumers on our site. We are providing power to our computing center out at the research campus, the Texas Advanced Computing Center, while also satisfying a transportation demand in the form of vehicles. If you'd like to see a fuel cell vehicle, walk out front to the area out front of this building. There are 2 Toyota Mirais on display out there. They are part of our demonstration project, and we'll be operating them here in Austin for about the next year, hopefully longer if Toyota allows us to keep them longer. But trying to put to practice some of the emerging hydrogen technology, some of the fundamental research that might be coming out of faculty members within the university, applying those in those kind of early stages, the pilot stages at our site, before they're ready for full-scale commercial deployments. This is especially important in these more like emerging hydrogen production technologies or end-use applications, right? Somebody's trying to improve, I don't know, how you make ammonia, right, at lower temperature or something. This site will be a great place to host that. get the data that can then feed back into economic analyses, right? Is it more efficient? How it might address the cost? At the same time, I guess it's going to make the business case for that startup as well. But that's what we're trying to do at the Center for Electromechanics and how we're trying to fit into this puzzle and advance hydrogen technologies.
That's great. There's not a lot of places you can go and see hydrogen in action, and so it's really cool that one of those is here.
Yep, and another plug tomorrow morning, if you want to tour it, come on out. There's also a video screen showing kind of a virtual walkthrough of it out by the eating area. So if you can't make it tomorrow morning, go watch the video for a couple minutes.
Great, thanks. Well, Emily, let's come to you, because policy is the glue that holds all this together, or in some cases doesn't. And it just is so essential, as we saw in some of the NPC work, the role of policy in not only advancing some of the early stage work, but really creating a viable longer term ecosystem for these solutions. So I'd love to hear more about how you're thinking about policy. What's the reality of this from your lens today?
Yeah, what a great question. Thank you for asking me about policy. I appreciate it. I think there are so many, we've already heard about some of the recent legislative action here in Texas. I imagine we'll see more hydrogen-related policy coming up in the next legislative session as well. And there are so many different avenues or aspects of the hydrogen economy where we would need to see the impact of policy. The NPC study has a lot of recommendations related to that. And maybe I'll just talk about some of the biggest ones on the US federal level that we have. If you are in the hydrogen space, you've probably heard about 45V, you've probably heard about 45Q. So maybe I'll take some time and explain what those are, and then also how we're incorporating them into our research and the impact from my perspective, our perspective on how that could bring hydrogen forward. So 45V is the Clean Hydrogen Production Tax Credit that was passed as part of the Inflation Reduction Act. As a policy nerd, I'll say it's a really cool and novel tax credit structure because it is tiered based on the carbon intensity of your hydrogen production. So the, quote, cleaner your hydrogen, the lower your carbon intensity of your hydrogen, the more tax credit that you can get. And so I think that's really smart as we start, some of what you showed, Austin, looking at the impact in the carbon intensity and what we really need to drive down low carbon intensity hydrogen production. So there are 4 tiers. If you are in the lowest tier of hydrogen production, so I think that's less than 0.45 grams of CO2 or per kilograms of CO2 per kilogram of hydrogen, you can earn up to $3 per kilogram of hydrogen. That tax credit also has a bonus eligibility. So to get the full value of the tax credit, you also have to meet prevailing wage and apprenticeship requirements. And that's sort of a standard bonus framework that applies across, if not all, certainly most of the tax credits that were included in part of that legislation. I think we'll come back either on this panel or over the course of today and talk more about workforce. But that aspect of it is incorporated into the tax credit value as well, which I think is really smart. The other thing that I'll note in talking about that tax credit is that they're based on life cycle emissions, which means that in addition to taking into account any emissions at your process facility, you also have to include emissions for electrolytic hydrogen, of any sort of electricity that's used to produce or run those electrolyzers to produce hydrogen. And it also means that you have to take into account any upstream emissions of methane if you're using some of those natural gas-based pathways. I'll sort of plug all of the posters that we have if you're interested in more of the technical work going on across UT, and I see there are lots of other universities represented here today to do, so that's really cool. We've done some work in our group, and there's a poster about it as well, looking at the requirements to meet those various tiers within the tax credit, using the tool that DOE has released, which is their 45V H2 version of Argonne's GREET model. To see essentially how much renewable or how much grid electricity can you have and still qualify for any level of the tax credit. Turns out not very much at all. How much carbon capture do you need if you want to qualify for the various tiers of the tax credit? Turns out maybe more than a lot of people are assuming. So feel free to go look at that poster or come talk to me. But that's one of the things that we're looking at, sort of the big mover that we're seeing in the United States for hydrogen. for hydrogen production specifically. The finalized guidance of that tax credit is not yet been released. So that's, I think, current maybe barrier, or at least holding back some of these market incentives that Ning talked about in terms of when are we going to see some of these contracts, when are we going to see sort of final investment decisions on these projects, because there's still some uncertainty in how the guidance and requirements for that tax credit will come out. The other one is the 45Q tax credit, which has been around longer than that, and that is the carbon capture and sequestration credit. So $1 per ton of CO2 that you capture and store or use. And so that would primarily be used, and based on some analysis that Ning has led, it looks like that for the natural gas thermal pathways utilizing carbon capture and storage, that will probably be a higher value tax credit, and that the 45V may be for the electrolytic tax credits. And then, of course, we'll also mention that another major federal policy is the clean hydrogen hubs, which I know we'll talk a lot about today, so don't want to belabor that point, but that's especially relevant for Texas since we got one of the hubs here. So.
Yeah, there's a lot happening, and that's an example of the domestic policy as well. Do you think about or get involved with some of the cross-border policy areas? I mean, this whole calculation is extremely important for the specific 45V, for example, locally, but then others around the world are doing their own calculations or have their own rules. Is that an area that you get involved with?
Yes, definitely. I've had the opportunity to spend quite a bit of time over in Germany over the past several years. We have a collaborator at the Technical University of Munich, and we've worked with them on doing some assessments of the feasibility of exporting hydrogen from Texas to Germany. So Texas and Germany are both leaders in the hydrogen space. Germany does not have the domestic energy resources to be able to produce hydrogen in the way that Texas does. I think this is a pretty common story for Texas compared to a lot of other places, and so we're sort of looking at the role for that. But if Texas or the United States were to export hydrogen to other places, like the EU or like Germany, they would be subject to some of their same regulations. And I think the lack of a harmonized global regulatory scheme is something that may, already appearing to be, may likely grow in importance in terms of a barrier. There are some similarities in the policies. So for example, for that 45V, in order to count as renewable electricity, there are the three pillars, which are the incrementality. You need new renewable generation that's been added to the system. And then there are also temporal and spatial requirements. So then you have to produce that renewable electricity at the same time and in the same location as where you are using it. The EU has very similar pillars in the way that they have structured their regulatory framework to define what would be renewable electrolytic hydrogen there. So we are seeing some of that. It's probably intentional attempt at matching, but certainly thinking about, okay, how do we, if in Texas we're developing a hydrogen economy that is going to serve both domestic uses across heavy industry, heavy transportation, et cetera, but also with the aim to export it, how do we make sure either that we're pushing forward regulatory schemes now that start from a harmonized space, or that we somehow develop hydrogen production and hydrogen infrastructure in Texas that can meet both of those standards? Right. So that's a really interesting sort of both technical policy regulatory question that it's kind of exciting to be at the cusp of the hydrogen space to think about how we can use our research and work with stakeholders to inform that going forward.
It's kind of where it all comes together, and you look at the work here at UT, you look at the high velocity hub and some of these things. It's that position of the confluence of all of it. Yeah. It's the technology and the realities of the resources, plus local development, export markets, the influence of policy on all of it. Another thing we talked about a lot, and this came up in the NPC work, was the importance of local stakeholder engagement, workforce development, education. Obviously, that's a core piece of the work here. Mike, let me come back to you. What is important for education in this space?
Well, it touches several areas right now, and it's not just engineering students that we would see here at UT. Yes, we need to bring up their education around hydrogen. All the fundamentals will still always apply, but applying them to this new application area I think that's well underway. We are getting so much interest from students wanting to participate in hydrogen research, like echoing what VB said. I don't go a week without a new postdoc or undergraduate student or graduate student that wants to work and collaborate with us. They are very excited about this hydrogen energy space. Yesterday's panel talked a lot about workforce development, more so on the skills and trades side of things. And yes, there's work to be done there. One great thing about hydrogen is a lot of those skills, maybe from oil and gas, do translate if it's at the right point within that hydrogen value stream, right? If it's moving the hydrogen around, maybe even making it at a thermal reformation plant, a lot of those skills are going to translate. I think where a lot of the education development needs to come from is the newer ways, the green hydrogen production pathways, right? Where suddenly we are now mixing, high pressure, dangerous gases with high voltage DC electricity, right? And the worker that's going to be trained and able to work on those systems, right? I know we have electricians and we have plumbers, but once you start working on an electrolyzer stack, you kind of need to have an understanding of both, right? Definitely on the safety side, especially when working around both those systems. And then just in the public community, and that where these projects will be going, there's education to be done there. What will this project bring to my community? Is this project safe? How is it safe? One of those aspects of educating those communities is potentially the local health impact, right? Whenever hydrogen is now displacing a fossil fuel use in your area. Despite the carbon aspects of it and climate change, hydrogen is going to immediately give you a health impact. That's what started a lot of the work in fuel cell vehicles 20 years ago. It was focused on, air quality and pollution, not climate change at the time. So those types of lessons to the community are important. And then what I'm getting a lot of feedback from here recently over the last 6 months or so as our proto hub is getting built out and people are coming to visit and see it, folks from industry such as yourself who are communicating to me that they are trying to work on hydrogen plants or projects in Texas. A lot of those are in West Texas, smaller communities, where there's a big educational gap with the city managers, the mayor, the regulatory officials, the authorities having jurisdiction. I talked to a gentleman from, I think, the Chamber of Commerce in Kerrville about a year ago. He calls me up asking, what is hydrogen? I've got this company. They want to make hydrogen here. He thought they were just going to drill for it. He didn't know any better. So I had, a 30-minute conversation with him, got him up to speed a little bit. But I'm getting a lot of feedback from companies that would like to use the Proto Hub site as a resource for that, just bringing communities, bringing the city officials or regulatory officials to the site to introduce them to hydrogen. So I think that's an interesting opportunity. And then I did want to maybe tag on a little bit to the international aspect.
Okay.
So UT, I think, is quickly finding itself playing an international role in hydrogen, right? Emily mentioned Germany and all of her connections there. For about the past 2 years, Emily and I have been holding a hydrogen class online where several students from Portugal are attending. I recently hosted researchers from the University of Tokyo. He was actually Egyptian. And also researchers from Sao Paulo University in Brazil, all working on hydrogen together, wanting to come study and work with us at UT to leverage our past experience and expertise there. So it's that educational outreach is even going globally here at UT. So
Yeah, it's really important. And I think those are some great examples. I mean, VB, let's build on this a little bit. You mentioned water earlier. Mike, you mentioned West Texas and some of the interests there. My question to you is a little bit different, but along the same vein. Really, what role do companies need to play here in workforce development, working with institutions like University of Texas at early stage through some of the research and then into the real applications out in the world?
So we need more engagement between universities and industries across the board. And on the educational front, I mean, industries look at universities as a talent pool for future employees. And as a university, we need to be developing this pipeline of hydrogen-trained engineers to supply to the future industry. And I don't know if we have a Hydrogen 101 class on campus, but we do need to have that and maybe a series of classes that are more about hydrogen and not about generalized energy systems. So we have classes on fuel cells and electrochemistry, but I think we can put together a suite of classes and maybe even have a certificate program on hydrogen, and that could translate to not just this campus, but other universities in the UT system. So I think that's something that would benefit industry enormously. And another aspect of this is partnering with, let's say, Austin Community College and community colleges to train technicians, and maybe not just train, but retrain people who are already active in oil and gas and get them up to speed on hydrogen and the safety standards that Mike talked about. So it's universities, it's community colleges. On the enterprise side of things, we have, like I said, we have a lot of smart people on campus who develop new materials and new technologies and new approaches to solving particular problems. And they're not very good at knowing what to do next. And I think that's another aspect where industry can step in. So we have Discovery to Impact at UT Austin, which acts as sort of a bridge between university research and the real world, which is industry. And we need more Chevrons and Exxons being part of that and being interested in supporting early stage ventures that might come out from all of the fundamental research that the government sponsors. So again, there's lots that need to be done, but it all starts with interest in industry in doing these sort of things. So in academia, we're always looking for funding and research projects, but I think faculty need to grow beyond that mindset and also think about enterprise and commercialization in a more broader and bigger sense than what I see happening right now. And in industry, we need champions, internal champions like yourself, and who are looking to universities to develop technologies, but then also be ready to absorb the risks and do the kind of risk mitigation and pilot studies before implementing it in a real world. So I think there needs to be more engagement, more excitement on both sides. And there is, but we need to channel that and streamline that to be more effective and productive.
Okay. Yeah, that's great. We started the panel a little bit early, so we may end a little bit early. But Ning, I want to come back to you, and then maybe we'll do a quick lightning round final question to close up. Ning, when we think about the markets and we talk about all the things that are necessary here, a lot of us have felt recently like some of the adoption is slower than we had hoped it would be. The policy is still being written. Policy is still slow. What do you say to maybe people that are looking at this and saying, wow, this is, we're excited, we have this great potential, we have the technology, markets are kind of slow, policy's kind of slow, maybe they get skeptical about it. What do you want people to hear about the realities of this and where we're going?
I know you saved a good question. Thing. So the way I see it is, it's true that, but I think it's really important to look at this is, right now we're at energy transition at this step. All the low-hanging fruits are pretty much tackled. I think for many of us being in the industry, and also my colleague talked about in UT, we have so much experience in the sector. we're kind of at the stage of energy transition because none of them is easy. I don't know about you guys. It's like, doesn't matter it's hydrogen or others. It's even for oil and gas right now, we have our own challenges in our sector. So I think it's at the sector that when people feel, oh, I'm not sure. Well, hydrogen was studied intensively before, and then it wasn't the right time for the market, and we're trying to gain. I think this time there's something different. There is definitely some value proposition stacking up, right? So the way I see it is when I tell people there is risk and the things that need to scale up, but it's not a way to say don't study it. I think that is the way I see it is it's about trade-off. I always say economists, we're not party poopers. We're just telling you about trade-offs. So we're just saying there's something you want to do, but there is costs. Decarbonization is expensive, like Austin, you were showing the MPC study. Decarbonization is expensive, so we have to be very careful about how we scale up. We have to really find the best alternative on the margin for each of applications. So make the task a lot harder. It wasn't like before, when we're just meeting the demand. Now we're meeting the demand, we're meeting the emission goal, and we're meeting the energy security. So we have like multi-criteria goals. So you get a lot more difficult system. So to me, I think the message is the same for anyone. It's like energy transition is getting to a hard position. We have to kind of push over the hump. It's not just hydrogen. I don't think personally that hydrogen's unique. If you study gas or you study grid, they all kind of at the point we have to move to the next step.
Yeah, and for me, this is really motivating because
exactly.
this is the moment for energy where we all have a role to play and doing new things while maintaining the reliability of what we have in this very, very complex system.
And
So,
I think that's one thing I want to add is, for education, I think that's one thing that's really important. We have a lot of students are very interested about it, and that's great. And I think that this is exactly the time. I always tell my students, either you go to hydrogen or anything else. The beauty is, right now, you kind of have a cross-cutting solution.
Right.
You go into hydrogen, you end up with something, you will end up with electricity grid, you end up with turbine. You have so many things, all kind of you have to know multiple things in order to find one solution. And I think that's one thing that's really exciting. That student, no matter which way they choose, you kind of is going to end up with multiple things you have to master to figure things out forward.
Right.
Yeah.
Oh, that's great. Yeah, I love that. That's really important, and I'm glad to hear that students have that enthusiasm about it, but it needs to apply to all of these challenges in front of us. So that's great. So just as a quick close, we've emphasized that hydrogen is happening, it's real. This is, all the elements are there coming together. We've talked a lot about collaboration, the partnership, the education approach. I'm going to start with Emily and move this way. Just what is one final thing you really want the audience to walk away with and maybe take to the conversations for the rest of the day here?
I think, Ning, as you were speaking, something came to my mind when we talked about some of the challenges, but also the opportunities as it relates to hydrogen. There's a lot of hype, there's a lot of excitement about it. And so I want to maybe temper some of that. Hydrogen can be used across so many different applications, but that doesn't mean that we should use it across all of those applications. That when we think about the whole portfolio of our energy system and our energy demands, and also all of the different tools that we have and will need to employ as we move along this transition, did you mention something like 8% or 12% hydrogen meeting final energy? So I think it's kind of important to, as we're thinking about a low amount of clean hydrogen to use, to really prioritize where we're using it and not get so far into the weeds that we miss thinking about its role across the entire energy transition, and strategic about making sure that we're identifying where we have the most synergies in our current energy system and the best opportunities, while not being so optimistic that we just go all in on it without remembering we have other tools we can deploy as well.
Yeah, so the challenges, but the opportunities that presents.
Yes,
VB, what about you? What is one thing you want people to take on their conversations today?
So it's somewhat unrelated, but I think most of the world today is captivated by AI, and nothing wrong with that. But many people don't realize the energy implications of AI. A chat GPT search is 10 times more energy intensive than a Google search. And this AI is just going to throw a lot of climate goals and targets aside. And so I mean, there's nothing wrong with AI. I mean, there's a lot of benefits to it, but the energy implications of AI need to be looked at. And I believe that hydrogen is as exciting as AI in the hardware sense. And hydrogen can contribute to a substantial portion of the energy consumption in the 2040s onwards time frame. And again, lots of opportunities for research, for enterprise, and that's what I would like to close with.
Yeah, it's great. I'm sure AI is going to come up in a lot of side conversations. It does for me almost every day. Ning, what's something you want people to take into the rest of the day?
I will say the exciting part is I'm glad that I'm part of this panel and this activity, because I think hydrogen is one topic out of many that it really stimulating the conversation between the commercial space and industry and academia, just very organically in the past 2 or 3 years, or maybe even longer, but I think it really speed up because there is a real need. There is a lot of gaps to be closed, and I think that's really exciting. And I want to say that, you know, our team actually developed a web-based tool, High Five. We're playing the video in the atrium. That was kind of a good example. We put GIS analysis, geological science research, and engineering, economics, all the different subjects together into an app that, you know, really supported by our students. So that's, you know, that kind of is a good example for what is a commercial need and what industry need and what our research and the students can do to kind of bring a very immediate need that what the industry needs is to screen and evaluate storage project for hydrogen. So that's something I just really think is exciting, and I hope that through today's activity, we really try to explore more this type of, you know, opportunity to work together.
Great. Yeah, we need to check that out. All right, Mike, you have a final word here.
Well, first of all, I'm going to say, VB, next time I talk to the dean, I'm going to tell him that you said hydrogen is as exciting as AI. So thank you for that. I'll be quoting you. And I believe it is as well. But I guess next year is our year, the year of energy, as Jay said earlier in his comments. Yeah, so my takeaway for hydrogen, I guess it just starts with maybe it might seem like a pretty daunting task, right? Trying to make this, well, transition is not the word, it's an addition, right? Adding something else to our energy mix. We will need more and more energy. Our demand for energy is outstripping our ability to deploy renewables. Hydrogen is going to be in that mix, right? It is one of our best solutions for decarbonizing many of our industries, right? If it's not hydrogen, I often struggle to think what might it be. And I get very frustrated at times when we are in panels like this, or maybe I'm at a battery panel of all things, okay? Where there becomes a lot of like, I don't know, fighting, or hydrogen's not a good solution because X, Y, and Z, or maybe batteries because of this and that. And like we need to get past that, right? Because we need all these solutions. They're different zero emission solutions, zero carbon solutions that have their fits in different places within our economy. And hydrogen definitely has that space. So I'd like to see the world get past that, right? We don't need to be trying to pick winners and losers here, right? Even in the applications of hydrogen, right? We want to start assigning winners and losers. You did in a plot up there. But maybe more winners, more applications become available too in the future as those applications make their way forward. But as you showed, it's very daunting. It's a lot of money. It's a lot of effort. But I keep trying to remind myself whenever I think about that, right? And trying to get motivated about doing this research is, you know, we didn't come onto this land with like railroads and highways already in place. The natural gas pipelines were not in place. The electrical power lines were not in place, right? We can develop that infrastructure that can connect all these markets and make it happen. But we have to decide this is what we want to do, right? So don't get caught up in, oh, it's too expensive. or it can never happen, oh, we can't change. We can do that, right? We've done it in the past. We can repeat that for hydrogen. It's not our first energy transition. Dr. Weber gives great talks about all the ways we transitioned our energy over the years. This is just the next one, and I hope we can all make it together in tackling this. Thank you.
Fantastic. I hear that as let's get to work. Yeah. So that's really good. Please join me in thanking our panelists for today. This was really great. Thanks.